Assalamu alaikum wa rahmatullahi wa barakatuh. Dear student of first secondary, we are going to start the new or second term for students of first secondary. We are going to have a new kind of chemistry. We will start with our points. We will illustrate completely all the points that we are going to study at this term. Okay, our unit in this system, we will start with thermochemistry, and we will discuss chapter 1, heat content. We will make revision for previous years that we are going to review the meaning of energy. Okay, let's start with our points. Okay, our learning outcomes here, we have to identify energy, initial position, final position, and work. We have to remember these definitions or these items that we have studied before. Number 2, we mention types of energies. We have different types of energies or forms of energies, and we want to know how to convert from one form to another. Third one, we have to define our curriculum or unit 4 of thermochemistry. It is a kind of chemistry that we will illustrate completely, and the meaning of heat as a form of energy. We will mention different types of systems in our life that we have. We have different kinds of energies in our life that system convert from one to another, and mention different types of heat assumptions or heat types that in our life, and we will make some checkpoints of our items. I made this for you to make a check for the new questions of Egyptian Knowledge Bank, and we will check our studying for the points that we are taking in our video. Okay, let's continue. Okay, what are going to illustrate at first? We are going to illustrate the meaning of energy. What is the meaning of energy? We have to know that energy means that we have the ability to do anything, okay, or it is the capacity or ability to do work or to produce heat. When you move from one place to another, you make a change in your body, so you feel hot or you produce heat. Okay, you have energy, so you produce heat. Okay, we have to remember that we are taking, or we have taken, that we have law of conservation of energy. What is the meaning of law of conservation of energy? You remember it? Do you remember law of conservation of energy? Okay, we said our body contain energy and we can't produce it, but it stored or change it from one form to another. So we can't produce it, but it will be stored in our body or stored in anything around us. Okay, when you have a ball stands in its place and you can move it, what happens when move it? It when it stands, it stored energy inside it. Okay, when you pull it, you have energy that convert from potential or stationary energy to what? To motion energy. Okay, let's discuss our law of conservation of energy. It is a very important law that studied before, that we are talking about energy neither created nor destroyed, but it converted from one form to another. It's a very important law that we are going to illustrate all items in our unit about this word. Okay, we will start with total energy content of universe is constant. Okay, why total content of energy in of the universe is constant? Why? As we have converted from one form to another, at the end all the energy are in stable state. No energy high or low or excited, but it stable or constant when we measure or when we change it from one place to another place. At all in the universe, all the total energy will be constant. Okay, let's continue our points. Okay, here we have the first kind of energy we will illustrate. We said that we will illustrate different kind of energy. We have here the first one of our energy kinds or forms of energy. We have potential energy. What is the meaning of potential energy? It is a potential energy due to position or construction of body, okay, or composition, due to position or composition. Okay, it is a stored energy that our body can be used. Okay, we have the second one, kinetic energy or kinetic energy. Some says kinetic energy, that is energy due to what? Due to motion or movement of an object. We have object that transfer or move or make motion, so it has a kinetic energy. We have a third kind, or this kind mainly depend on two things. Okay, depend on what? The first one, we have mass of the object. You are, if you are with a light mass, so you can run fast as amount of body is small, or the big one can't move very fast as it has big mass. So the kinetic energy depend on the mass of the object or the body, and second one depend on the velocity or speed of the body. So if we make connect between potential and kinetic energy, so potential, its rule or law says weight of the body affected due to its stationary state time height, or its height from the earth. And also kinetic energy, its rule says that half time mass time square velocity or speed power 2. So if we take potential energy, summation of potential energy and the kinetic energy, we said that we have law of conservation of mass. Okay, law of conservation of mass that we have, or law of conservation of energy. Here we have potential energy, summation of potential energy and the kinetic energy under the effect of gravity is constant. Okay, it is the same as we say before in another way of our energy. Okay, let's going to continue our kind of energy. Okay, let's look at the drawing in front of you. We have here two balls, one of them held up in this place, ball A and ball B. Okay, what happened in the other picture? We have ball A here fall downward and ball B falls upward. Okay, here we have two positions in our drawing. We have two positions in our drawing. The first one we called it initial position, and the second one we called it final position. What is the meaning and what is the difference between them? Okay, we have here initial position means that in the initial position, ball A has higher potential energy than ball B as it comes in above place. But in the other picture, we have here final position. After rolling, ball A make a change and transfer to the other side, so it make down the hill, and potential energy lost by ball A transfer to the transfer to ball B at the end, and movement will happen to ball B to put up or rise in the energy as it will be in a high position. Okay, I think it's main point that we will discuss after in details. Okay, let's going to continue. What is the meaning of energy? Okay, or how we can use energy. Energy involves the transfer of energy between two objects. Due to what? Due to if we have two objects have difference in temperature, that they will be have a change in what? In the energy. Okay, we depend in our unit on the heat, or we can say thermal energy in the new word, that we will transfer from or between two bodies depend on the temperature of each of them or the difference in temperature. Okay, if we want to make a position or to make push to anybody, we make push or force acting over a distance. So we have here the definition of work equal force time displacement or distance in a certain direction, we called it displacement. So work equal force time displacement. We remember all the rules that we studied before in the previous years. Okay, let's continue. We said that energy in a state function or work and heat are not a state function at all. Okay, we said state function means what? Means a property doesn't depend on in any way on the system, or due to it depend on the present state at we are talking about. If we are talking now, we are talking about the state of your body now, not before or after. I take this state or energy in the present condition. Okay, so we say it is energy is a state function. Work and heat are not state function. Okay, remember this very well. We are not talking about work or heat. We are going to talk about only what? Only form of energy that we are going to illustrate. So energy, it is the capacity to do work. We have different kinds of energy. Also we have thermal energy. What do we mean by thermal energy? Energy associated with random motion of atoms and molecules. Okay, if we look at the boiler that or making a boiling for water, we will see that make convection or rotation of the water molecules inside the boiler. So here we can see the thermal energy make a random motion for the atoms and the molecule inside the boiler. Okay, we have another kind of energy, thermal energy. It is the energy stored with bonds of chemical substances. Okay, if we have any chemical substance like what? Like water, it is a chemical substance. So there is a stored energy inside the water. Which kind of energy? van der Waals energy, or we can say it is a inside energy that make the molecules of water forming a covalent bond that connected together after adding any substance by making stirring that can make connection between them during the chemical reaction. Okay, we have another kind, nuclear energy. It is the energy stored within the collection of neutrons and the protons in the atom. Okay, we have here different definitions. Okay, the first one, we said that we have thermal energy and chemical energy. Nuclear energy, it is the energy that we use by depending on what the component inside the nucleus. What is the component inside the nucleus? We have neutrons and what? Protons. It is a very huge energy. We will discuss it in unit 5 completely. Okay, electric energy, we studied it before. It is the energy associated with the force of electrons, or due to the movement of electrons, as electrons at all are kind of charge that have a negative charge and transfer along the electric wires. Okay, we have potential energy also. It is the energy of the body or stored in the body due to its position, and we can change it by changing its position. Okay, what is the energy changes in chemical reaction? We will have heat energy. It is transfer of thermal energy. We depend on our bodies. When one of them have higher temperature, it will move to different less temperature. Okay, or it's a thermal energy between two bodies due to different in temperatures. Due to what? Due to different in temperature. So we can take temperature as a measure of thermal energy. If we can express that we have here a thermal energy, so we can mention the word temperature as its temperature will be this number. Okay, and at all, temperature not a thermal energy. Temperature is not a thermal energy, as we have a temperature of ice cream. It's a cooling temperature, not thermal energy here. Okay, you understand it? If we can take a shower, okay, we can mention, we depend on thermometer to measure the temperature. But in case of, if we touch the hot cup of tea, we can see that it has high temperature. And if we take a shower with temperature 40 degree, so we can measure it by thermometer, as we have temperature here measurement. What? Temperature measurement for the degree, not measure of thermal energy. Okay, so we can't depend on our sense to measure the temperature. We must depend on what? We must depend on thermometer or a device that we use to measure the temperature. What is the meaning of thermochemistry? It is the title of our unit today. What is the meaning of thermochemistry? It is the study of heat change. What will happen? Heat change means that changing in the content of our chemical reaction, or change in properties of it. If it has high heat energy, it will transfer from it to area around it or opposite to it. Okay, if we are going to discuss all these points, we have in our universe, we have system. System is part of our universe. Okay, we have universe all. We have two components in our universe. We have system. It is a specific part that we are talking about it. And around this system we have what? We have surrounding or a rounded area. Okay, what kind of systems that we have in our universe? Okay, if we have system and surrounding, one kind of them make exchange between each of them, between system and surrounding. Okay, we have here in the drawing different kinds of systems in our universe. The first one, we have open. What is the meaning of open system? We have here in the drawing, we have glass bottle and water vapor exploded without cover or without lid for it. We have water vapor coming out from the bottle. So we can call it open system. Why? As it make explode to the water. The second one here, we have called it closed system, and the third one we called it isolated system. What is the difference between each of them? We have different kinds of system here. The first one, we will compare between 2 points. Okay, if we can measure any kind of system, we have two things. We have to measure what? Mass and energy. Okay, we said that we have bottle without lid. What happens when we have bottle without lid? Water vapor will explode outside. So some water, like a water vapor, so will be decrease in mass and energy transformation here due to the effect of surrounding on the bottle. Okay, if we have a bottle containing ice and we put it in the air without any heating or cooling, we have drops of water surrounding it, so it will make here exchange of mass and energy with surrounding. So the first one, open system make exchange between surrounding and system. Exchange for what? For mass and energy. We'll take choices, or we will make questions a lot for this kind of systems. Okay, the second one here, closed system. Okay, if we put the lid of the bottle here, so it will be closed. After that, we affected on the bottle by heat around it, depend on cooling or heating. So we have here a closed system. Okay, so we make exchange for energy only. As we close the bottle by the lid, so there is no exchange for what? For mass. The third one, isolated. What about isolated? It's our system, or it's a thermodynamics or thermochemistry that we are studying. We have isolated system. That means we don't exchange mass or energy with surrounding. You have, if you said that you are concentrated to study, so you will be isolated from any area around you. So there is no exchange, nothing for what? For mass and energy between them. Okay, look at the drawing in front of you. We have two kinds of processes that we are talking to illustrate. Okay, the first one here, if heat comes out from system to surrounding, or energy, so if we have hot cup of tea and after the time it will be cold, so which high in temperature or which has high energy that changes to the other? The hot cup of tea make transfer of energy to the surrounding. So from system to surrounding, energy will be transfer. So change will be in a negative sign or in what, less than 0, and we can say the reaction will be exothermic reaction. Okay, this is the first one, or exothermic process. It means that any process that gives out heat or gives off heat, so the thermal energy from system to surrounding, we can call it exothermic reaction. Okay, like what? If we have a very important reaction, we have here reaction between hydrogen atoms and oxygen. It's a very huge reaction to form water. This kind of reaction here we have, okay, we will make a break for the bond in pure covalent for hydrogen and pure covalent for what, for oxygen, and after breaking we will form a new bond. It's a two single covalent bond inside the water, but it will give a high amount of energy. It will give high amount of energy, so it will be exothermic reaction. The amount of energy coming out from this reaction we can use it to form a fuel or use in the space, as it will make a boiling or heating for any drops of water in the air, so we can take energy from this reaction. Okay, also if we make a change from water here in the case of gas to change to liquid, so it will what, it will make a condensation, so it will changes from gaseous state to liquid state. Okay, as we collect all the molecules of water, so it will release energy. Okay, we have the second kind of reaction or process. Here we have endothermic reaction. Okay, if you are cooling, you need to take energy from anything around you. Okay, what happened? You will put your hands surrounding a hot cup of tea, so you need to take energy from this cup to feel hot. So energy will coming from surrounding to what, to system, so we can call it endothermic reaction, and the change in energy will be greater than 0, so you feel hot or you feel that you are warmer, that the energy transfer from this cup of tea to your body or to you to feel hot. So without giving energy from surrounding, you didn't feel warmer. It's a kind of reaction depend on the presence of what, force that you give to your system. Okay, so we have endothermic reaction. It is a process in which heat what, comes into the system, okay, from surrounding. Heat into comes from the system into surrounding. Okay, we have here a kind of reaction if we have a solid water, or if we have any kind of solid, like what, like mercuric oxide. We take it before in the previous year that we have mercuric oxide. It's a kind of oxide that if we make change to it, or if we take the compound and make a heat reaction or make thermal decomposition to it, it has its oxide, red mercuric oxide. After giving the heat, it will make thermal decomposition to it and will give mercuric in the silver or black color, and oxygen gas evolves. So any kind of thermal decomposition will be what, will be endothermic reaction, as we will enhance the reaction or giving energy to make the reaction. But in case of thermo or exothermic reaction, and we will take energy to the surrounding, so the energy will be coming on the other side here of the reaction. But in the endothermic reaction, we will have energy to begin the reaction at the end, at first. Okay, do you think what we are going to discuss a lot of questions about this kind of reaction. We have here energy to make the reaction of water, changes it from solid state. We take energy. So water molecules, if we have a bottle of water, of inside it ice, that we take energy from air surrounding it, so we will see a drops of water make a condensation, so it will make what, it will be endothermic reaction, and it will change to liquid state also. Okay, we will discuss our points today. We will make a check or concept check for our points today. Let's start. Classify each of process as exothermic or endothermic reaction. Okay, we will start. System is underlined in each example. We have here, your hand gets cold when you touching. Okay, your hand here, that it is a system that we want. When you make a friction or touching it, your hand gets cold when touching iced tea. What happened? Why? Okay, it will be what? It will be exothermic. Your hand gets cold when touching. Why? It will exothermic. Okay, it will exothermic. Okay, second one here we have, the ice gets warmer when you touch it. Ice, when you touch it, will be melt, so it will be warmer. So you give heat to the ice, it will endothermic reaction, right? Yes, you understand now. Another one, we have water boils in the kettle when heating on a stove. Okay, you give heat to what? To water, to change it from liquid to vapor, so you will enhance energy, so it will be what? It will be also endothermic reaction, right? You understand now every point. We have here water vapor changes or motion on cold pipe. Water vapor here, okay, condenses on cold pipe. It means that we have here changes from water vapor as a gas, make exchange to liquid, so it will be collecting to it, so it will be what? It will be coming out heat, so it will be exothermic reaction. We have the last one here, when ice melts, it will be what? It will be endothermic reaction. It is a very important example here. Ice melt depend on that it will take energy from surrounding air, as the air surrounding ice has high temperature that push energy to the ice, so it will melt. It will be what? It will be endothermic. We have another points here. Is the freezing of water an exothermic or endothermic process? We have freezing of water, changing it from liquid to solid. So you will give energy to water to change it. So it will be endothermic reaction. It will be what? Endothermic reaction. You will give energy to change water from one state to another, so it will be endothermic reaction. Okay, another we have here question, what type of reaction occurs in hand warmer? Okay, hand warmer means that it conserve energy inside it that we will comes to us. Okay, or hand gel, hand warmer or hand gel, so it will be coming energy from it, so it will be exothermic. It will be what? Exothermic or endothermic? It will be endothermic, as it will make what? Make coming out reaction from the surrounding, so it will be endothermic reaction. It will be what? Endothermic reaction. We have another kind of reaction. If a chemical reaction is exothermic, it means that the temperature of surrounding would do which of the following, okay? We have stay the same, second one increase, third one decrease. If we have exothermic, so the energy or temperature will be increases as we feel hot at the end of reaction, okay? Another question here, we have what very important process in our life? We have photosynthesis process. What happened in photosynthesis process? Which type of reaction is photosynthesis? Okay, if we haven't chlorophyll, with the presence of what? With the presence of photovoltaic energy of the sun, okay, it will enhance the reaction of taking carbon dioxide and water to make what? To make this process. So it's very important to know that this kind of reaction, we can say it will be what? It will be endothermic reaction. It will be what? Endothermic reaction. Another question. Checkpoint for our, it if it takes more energy to make bond than break one. I give you energy, so it will be end. I will push it to you. The reaction of the following. The reaction will be what? Will be coming more energy to make bond than break. I will need energy, or the reaction, which of reaction will be you take more energy to make bonds than break. We will break at the end, or we will form at the end. It will be exothermic. It will be what? Exothermic reaction. It will be exothermic. Thank you for our joining. This is the first session for second term. We will continue our unit. I hope you enjoy this part. It is just introduction for our unit. Wait for another sessions, and I hope you enjoy this. Waiting for your questions on the channel. Okay, goodbye.